So I'm not going to be as poetic as the last three speakers. There's no way. I can't speak Hebrew that way. It's sort of poetry. And it's beautiful. But I am glad to be here, and I'm going to start before I do the first slide and give you a little bit of the connection of why it's important and why this actually needs to start the conference and not be in the afternoon. Needs to start the conference because the future starts with the children, with the kids. It needs the attention of the larger room. So it's my personal opinion, I don't speak for NASA or NASA Ames in that opinion. And I say that because I remember coming here and meeting Rona and doing an outreach talk and going for the dinner with the family. And as much as you see me, I am a very shy person. My job makes me not shy, but I am shy. So when I go to a room, I'm usually in the back. And Rona called me to sit next to her, both at the dinner and when we went to the meeting. And I'm sorry because it is emotional. But that is what education is about. It's about the person that's shy. I can't, every time, and I said this to the family, I can't imagine doing this conference every year and having to go and talk to the audience. It's quite difficult for me, and I'm not the family. So I will give you, I have 10 minutes, and it says I have 7 minutes and 50-something seconds. I'm not very good at following rules because I grew up in New York, and I have some Israeli blood. But I'll try to stay in 10 minutes across there. And so you see a title. I reuse some slides every so often. You see this title, and you see my title, but the title doesn't mean anything. The title is just a tool to do things. It's to open doors across there. And so this talk is about exploring space, but it's in a different way. And if you saw the talk yesterday, you will see some of the same slides, but you will be surprised. So I'm assuming this will work. Sooner or later, we could get to the moon, but it's always nice when you go to like at NASA and you try to work on the computer.
Just a minute, we're going to put it again.
Very good. Yeah. Until a virus gets into the AI. Then what happens? You know why you get a PhD? Get a PhD because you could forget everything. You have somebody clicking, somebody doing. It's great. It's retirement and you get paid for it across there.
It will take just another minute, I'm sorry.
So let me continue and talk a little bit about NASA. The reason why I'm at NASA is I think they're good enough. I'm looking at how many students are here, and I don't see that many. The reason I'm at NASA is because I skipped school for 2 reasons while I was in junior high school. The first one is to see Star Wars, the original Star Wars. We could talk about new Star Wars versus old Star Wars. The second part is to see the space shuttle launch. I saw all of them. I saw Challenger. The ones I didn't see were the ones that were secret, so they didn't have them. And then I got to go and actually see shuttle launches with Carl Waltz, which was an experience. So it's really important, but NASA itself does many things. It attracts a lot of people. The reason we started to attract people is because we went to the moon. And currently, we're going back to the moon. And when we get the first slide, you will see the map. How is that first slide going, by the way? I have the stick and memory stick if you want to try again across there. So if you look at going back to the moon, it's done on stages. And it's done on stages on multiple parts. It's done this way for a couple of reasons. One is for risk mitigation. The second, it actually becomes more economical as you develop your processes, going from one place to the other, from low Earth orbit to the moon and back, going to Mars and beyond across there. I'm looking to try to figure out how the slide is going across there. So for most students that you will have, they're younger. Ooh, look. Did you have the clicker? No, go back.
We'll give you another clicker.
Go back. No, you're going forward. Go back. There you go. Thank you. Okay. So perfect. This is a small enough crowd that I could actually not use this, but I will use this. So this is the map of Artemis and human exploration. But human exploration requires also science and technology. And what you will see is that it requires a lot of steps of understanding how we survive on the moon. It's not just a trip where you visit it and going away. It's, I'm going to live there. How do you do that? What are the requirements there? What are the science and technology development that comes here? Now, when you look at this, it might look complex, but it would also, the other picture of it is that anything that you're interested in is actually in this map. Everything. So if you want to use it as a tool to teach, you could talk about every single topic. But I am not a rocket engineer. I am a biologist. Yes, I see some faces. I am not biased in what I'm going to say right now. I have 3 minutes, so I'm going to have to move a little faster. But biology is the unified theory. It includes chemistry, it includes physics, it includes math. I'll argue with all the scientists who disagrees with me on this. So let me move, because we do have 3 minutes. But I think the most important question is, are we alone? You know, I'm religious. If you want to look at religion from a non-religious aspect, the question is, are we alone and how we got here? So are we alone is the largest question. So how do you determine, are we alone in space? So I'm going to show you some key things to determining, are we alone? Space is really blank. It's dark. It's not white. So the first step of determining, are we alone, we hope, is what are you looking for? What is life? How do you identify life? Well, this is some charts. This is going to be actually a more technical talk in BGU tomorrow, so it's going to talk about something else. But in this perspective, it's what are the signatures of life? Is it organic? Is it protein? Is it amino acids? Is it chemical complexity? That's important, because if you don't know what life is, you won't be able to test it or detect it. So what you're looking for is really important. The second step, wow, I'm at like the technology country. Wow. Okay, it's where you look. So if you look at the top, you're seeing an image of the Kepler field, which was from NASA Ames, so of course I'll use it. And it shows that there are habitable planets everywhere you look in the universe. What does that mean? It means that they could have liquid water on them. You go down, it's our solar system. Well, if there's life on Earth here, well, wouldn't our next door neighbors might have life on them? That's another place to look. What you see on the bottom is some work that I do with a colleague. If you were to go on Mars, let's say, where would you look? It's a giant planet. So if you think that it's organic, you would look at Earth and try to determine where the signatures will be across it. So where is important to understand. The last one is your sensitivity or the abundance of your signature. Most planets are cold. That means if there was life on there, it wouldn't be large and numerous everywhere. It wouldn't have lots of predators. There's not a lot of energy in there. So the abundance is important. And so you say, Why is J'iaykob saying this to us? We're not biologists. This is an education form across here. So let me show you this in a different way. I have an aquarium with water and rocks in my teaching class. That is the universe. The bottom will have bacteria. There'll be microorganisms in the water. If I add salt, it's a different environment, and everything else will die on top. I could teach what is the signatures. Do I look at it with a microscope, or do I stain for proteins, or do I isolate DNA and RNA from the bottom of the rocks and the pebbles to show that there's life in there? The where. Well, where? Is it up where there's oxygen? Is high amounts of organic material important? What if I flood it with fertilizer? Will I have more life, less life? How do I determine it? The last one is abundance and sensitivity. If I have little amoebas and other creatures floating in the water and I'm looking under the microscope, if I pick 1 microliter, would I see something? Or do I need to pick 10 mils to see it? That's a big difference. If you're digging for a rock on Mars, how much sample do I need? How deep do I go? Where do I go? So using space to teach basic science does not require a space flight. It requires looking at the world in a different way. If you see the world in a different way, maybe we'll solve some of the issues we even are dealing with right now. So this is why this slide is shown here. I could talk about it from the scientific perspective, trust me. But this is more about how do you teach? How do you inspire the student to understand that there's things around them right now that we don't know? You don't need to go to space. You don't need to be a physicist, a biologist, and so on, to look around you and find new things to understand. I think I have 1 minute. 1 minute and 13 seconds. So I'm going to tell you I'm going to be over, but not by much, just because I want to be over. So I apologize to whoever is next. The other thing is, if you look at all the kids now, they really like gaming. They like surfing the net. The next wave is this virtual reality, augmented reality, and all of those. It's a great tool for education. Why? Because you could connect different people. They don't have to look the same. They could look different. But also, it's tools that are important for the future. You do risk mitigation with augmented reality. You're able to learn how to do surgeries when you have the tools. So understanding how to use this as a tool for education also allows them to be prepared for the next step in what the world will be across there. So it's just the beginning, but it's good to be at the start of the tool that's there. So I typically end the talks in this statement, which is the key to long-term success in life. Oh, by the way, I finished this talk. Well, I sort of was sleep deprived, so at 4 o'clock around is where I got the idea of what I'm going to do. So I'm actually going to be longer than 1 minute over, just because I just remembered I have a few more slides. So I apologize really now. So this is what I was going to finish with, because I usually put this sentence of key to long-term success in life in all my presentations. Rona really exemplifies that statement. You know, she was really amazing. But yesterday, I had a long day. So I got to see this. And I got a lesson. And the lesson is really important. It's important to remember the past, but it's also important to look for the future. So it was an interesting conversation, actually. And it changed what this talk is about. So the talk isn't going to finish that way. It's going to finish a little different. It's going to finish about a class that I talked to yesterday in Ramat Gan. It's about all the kids that were excited, that asked me questions, some of them that probably I shouldn't have answered because they weren't politically correct or whatever it was. It's about this, right? This is what it's about. So now I'm going to finish the talk. And so the key to long-term success in life is imagination, persistence, and compassion. And it is about the future. And what you're seeing in this picture, you're seeing somebody who's not so good looking. That's me in the center. And next to me is my 3-year-old girl that's saying, Abba, I want Abba right now every night. And if you can't figure it out, throughout the talk, you saw her favorite color, which is purple. So now you see it at the end, but if you go back to the talk, you'll see on every page there was purple. So really, thank you very much for the talk. I am 2 minutes and 30. We'll round it up to 3 by saying thank you again.